Hello everyone, my name is Vaidehi Chaudhary. I am the student of the MIT Academy of Engineering, Alandi, Pune. So there is a School of Civil Engineering and my presentation topic is Earth Pressure Theory was guided by the Professor V.V. Muteka sir from MIT Academy of Engineering, Alandi, Pune. After that, in this presentation, we will think about the lateral earth pressure theory, which is known as the earth pressure at a rest, general local shear failure at the plastic and the equilibrium, Rankine's and the Coulomb's theory of the active and the passive earth pressure on the retaining, influencing of the structure, water table, wall frictions, etc. After that, we are seeing about the common types of the retaining walls. As we know, the basement wall, BMM wall with the wire basket filled with the stone and the rock, reinforced earth wall, concrete wall, gravity wall, reinforced concrete cantilever wall, crib wall. Such type of walls are generally known as retaining walls. And after that, we are seeing about what is the types of the lateral earth pressure and how we can define the lateral earth pressure and which are the needs of the lateral earth pressure. So for that purpose, we are computing the lateral earth pressure is required in the analysis and the designing of the retaining structure. In this chapter, the determination of the lateral earth pressure on the rigid retaining walls is the depth width. The designing of the retaining wall structure requires the determination of the magnitude and the line of action of the lateral earth pressure. The magnitude of the lateral earth pressure depends upon the mode of the movement of a wall, flexibility of the wall, properties of the soil, and the drainage condition. As we know, the lateral earth pressure was the pressure which is defined by the soil, and this depending upon the mode of the movement of a wall means whenever the wall is moved and the flexibility of the wall, properties of the soil, drainage conditions of the soil. The problems of the determining the lateral earth pressure has been investigated the both theoretically and by the experimentally work. Since as far as the back of the 1860, when the Rankine proposed his theory considering the plastic equilibrium of the soil to quantify the lateral earth pressure, three types of a lateral earth pressure depending upon the three possibilities condition have been considered. They are lateral earth pressure at a rest, active earth pressure, and the passive earth pressure. Earth pressure at a rest at means the example of the bridge abutment. Then active earth pressure as the example of the wall moves away from the soil, and the passive earth pressure was the example of the wall moves towards the soil. After that, we will see what is the lateral earth pressure means active earth pressure and the passive earth pressure. When the wall is a move when the wall is a move away from the wall, away from the backfill, which is known as the active earth pressure, and as the wall is a move towards the backfill, it is known as the passive earth pressure. This is the examples of the lateral earth pressure depending upon the strata and the failure wedges, sigma, h, and the height of the retaining wall and the displacement of the wall, which is the if we wall is a move towards the backfill, it is a passive earth pressure, and away from the backfill, it is a active earth pressure.
So now we see what are the types of a lateral earth pressure. There are the three types of pressure, that is at rest pressure, active earth pressure and passive earth pressure. At rest pressure what means? The earth pressure exerted by the retained wall soil mass on the when the soil is not subjected to the any lateral earth movement occurs when the retaining wall is firmly fixed at its top and it is not allowed to rotate or to move laterally. When the base of the wall is assumed to be rigid, fixed, and then the wall does not move, the pressure exerted by the backfill on the back of the wall is reflected to the earth pressure at a rest. At a rest condition, it is known as elastic equilibrium. At the earth pressure, active earth pressure, the active earth pressure occurs when the soil mass is not yield in such a way that it tends to stretch horizontally. When the base of the wall is yield and then wall the moves away from the field, the earth pressure decreases on the certain minimum value. The minimum value of the earth pressure is referred to as active earth pressure. It is a staticoplastic equilibrium as the entire soil mass is on the verge of failure. In the active earth pressure, the wall is moved away from the backfill, and in the passive earth pressure, the wall is moved back to the backfill. When the base of the soil mass is held at a wall moved towards the backfill, the earth pressure is increases to the certain minimum value. That the maximum value of the earth pressure is referred as a passive earth pressure. Passive earth pressure occurs when the soil mass is compressible in horizontally. Then when the earth pressure at a rest exerted on the back of the rigid retaining wall can be determined using the theory of elasticity, assuming the backfill soil to be elastic, homogeneous, isotropic and semi-infinite. Consider an element at a depth of the z below the surface of the backfill. Let the sigma v and a sigma h denoted the vertical and the horizontal stresses acting on the element, as shown in the figure. In the absence of the shear stresses on the plane, that is a ZAV and a ZH, the lateral strain sigma h in horizontal direction is given by this the equation. For the condition of the earth pressure at a rest, the sigma h is equal to 0. Then there is a derivation of the equation, and the final equation is concluded that the K0 is called as a coefficient of the earth pressure at a rest. Then the Rankine's theory of the earth pressure. On this earth pressure, the Rankines proposed his theory and some assumptions was denoted by the Rankines. That is, the soil mass is homogeneous and semi-infinite. The soil mass is on the cohesionless and the dry. The surface of the soil is the plane, which may be the horizontal or inclined. The back of the wall is a vertical. The back of the wall is a smooth, so that there will be no shear stresses between the wall and the soil. Because of these assumptions, the stresses relation between any element adjacent to the wall is the same as that the any of the other element away from the wall. The wall yield about the base, and thus the statics the deformation conditions for the elastic equilibrium. Because of the assumptions of that there is a no friction between the soil and the wall, the resultant earth pressure must be parallel to the surface of the backfill. However, there is a practice that the back of the retaining walls constructed masonry, concrete, will never smooth, and the resultant active earth pressure will be inclined to the normal of the back of the wall, and angle of an equal to the angle friction of between the soil mass and backfiller. Means there is the angle of the friction and the angle of a wall, that is the shear failure or that is the verge of a failure, as equal. After that, there are some conditions of the earth pressure which can calculate by the dry or the moist backfill with a no surcharge. The consider an element at a depth of the z below the surface of the backfill. Let a sigma v and a sigma h denoted the vertical and horizontal stresses acting on the element. In the state of the plastic equilibrium, we have the sigma 3. Sigma 3 is equal to sigma h and sigma 1 is equal to sigma v. That is, the relation between the principal stresses and the plastic equilibrium condition is sigma 1 is equal to sigma 3 tan 2 phi plus 2c tan alpha, where the alpha is the degree of a 45 plus phi by 2, and phi by 2 means phi is the angle of the friction, that is the angle is the verge of failure. Then the second case is a dry or a moist backfill with a no surcharge. For the cohesionless soil, the C is equal to 0. Therefore, the sigma 1 is equal to the sigma 3 tan 2 alpha. Sigma v is equal to sigma h tan 2 alpha. Sigma h is equal to tan v cot 2 alpha. We write a sigma h is equal to Ka into sigma v, where the Ka is equal to cot 2 alpha is equal to 1 minus sin phi upon 1 plus sin phi, where the K is a uh, coefficient of the earth pressure at a rest. And Ka is also called as a Rankine's coefficient of the active earth pressure. Then there are some equations we can derive by the Rankines. When for that purpose the passive earth pressure was derived by the Rankines, that is a 1 by 2 Ka gamma h into h, that is the area of the triangle, is equal to the half into base into height. The Pa is act at a distance h by 3 from the base. Pa is also can be denoted as shown in below. Pa is equal to the integration of the Ka gamma z into dz, that is the constant is outside the integration, and the integration of a z to the dz is equal to Ka gamma into z2 by 2 into 0 to h, that is a 1 by 2 into Ka into gamma into h2. After that, the second case of this backfill with the surcharge. When the backfill is with the surcharge, then the Q per unit acting on the surface at any depth z, intensity of the active earth pressure can be calculated with the help of a Pa is equal to Ka into gamma h plus Ka into Q. Ka into gamma z, it is a uniformly surcharge, and Q is the intensity of the load. That is at z is equal to 0, Pa is equal to Ka into Q. At z is equal to h, Pa is equal to K into gamma h plus K into Q. The active earth pressure distribution as shown in the figure. Let the resultant of the active earth pressure per unit length of the wall is act on the distance above from the z. After that, we have the P1 and P2. P1 is equal to the K into gamma h acting on the distance from the h by 2 from the base, and P2 is a half of k into gamma h2 acting on the distance from the h by 2 from the base, sorry, h by 3 from the base. Resultant active earth pressure is equal to Pa is equal to Pa1 plus Pa2. Pa is equal to gamma Q, K into Q plus h by 2 into gamma h. After that, the third case is a fully submerged backfill. The active earth pressure distribution is shown in the figure. The resultant active earth pressure is given by the area of the pressure distribution diagram. Pa is equal to half into K gamma H plus K gamma W into H is equal to half into K gamma H1 plus gamma WH square. These forces are acting on the distance from H by 3 from the base. After that, the fourth case is the partially submerged backfill. That is shown in the partially submerged backfill with the help of no changes in the phi on the submergence, where the 0 is in between the Z and in between the H. Pa is equal to gamma into Z, that is uniformly surcharged. That is at z is equal to 0, Pa is equal to also 0. At z is equal to h1, Pa is equal to Ka into gamma h1. For the h1 is in the between the z plus h, then the Pa is equal to K into gamma h1 plus Ka into gamma 1 z minus h1 plus K into gamma w z minus h1. And at z is equal to h1, the Pa will be K into gamma h1. At z is equal to h, Pa will be gamma A into h1 plus Ka into gamma 1 h1 minus h1 plus Kw h minus h1. So these are some cases or was submitted by the Rankines or proposed by the Rankines, and these are some equations we are having the for solving the. Thank you.